So let's discuss a problem from thermodynamics. So this is related to the coefficient of cubical expansion of liquid. So the problem is a sphere of diameter 7 centimeter and mass 20 266.5 grams floats in a bath of liquid. So we need to consider a bath of liquid. So this is some liquid like that, some sort of liquid. So this is filled with liquid, and here what they are saying is a sphere of diameter 7 centimeter and mass floats in a bath of liquid. So here we need to consider a sphere. So it is floating in this liquid. As the next thing is, as the temperature is raised, the sphere begins to sink at a temperature of 35 degrees centigrade. So as we are raising the temperature of this liquid, so when we heat this liquid, so what is happening to heat it to 35 degrees centigrade? So this sphere initially when it was floating, so after heating it tends to sink down. It is sinking down at 35 degrees centigrade. So this was the case when the temperature was 0 degrees centigrade. So it was floating. The sphere was floating at 0 degrees centigrade. But when the temperature has been changed to this 35 degrees centigrade, it is now it is trying to sink. So if the density of the liquid is 1.527 gram per centimeter cube at 0 degrees centigrade, so they have provided us with the density of the liquid at 0 degrees centigrade and find the coefficient of cubical expansion of the liquid. Cubical means volume expansion. So that one we need to find in the 3 dimension. Neglect the expansion of the sphere. So this is very important point to be noted. So we need to neglect the expansion of the sphere. So here, why the sphere was initially floating and next it is trying to sink means we need to understand here that when the density of the sphere, for suppose, so when the density of the sphere is less than water, so density of sphere, when the density of sphere, let us indicate with the actually it has to be indicated with rho. So for simply now, so okay, with rho we would indicate. So when density of the sphere is less than the density of the liquid, so it tends to float. And when density of the sphere is greater than density of the liquid, it tries to sink. So this is the condition, hence here it was sinking. So here we need to observe whether the sphere's density is increasing or not. So this is only possible if whether the sphere's density has to be increased or else the liquid's density has to be decreased. So these are the two possible cases. So here they have said that neglect the expansion of sphere. So if we are heating this liquid, so the heat also passes to the sphere. So because of which it also might expand. Because of which its density might change. But here we are supposed to neglect the expansion of the sphere. So if we neglect the expansion of the sphere, if we keep that aside, so on heating what happens? That one first we need to understand here. So initially the molecules will be very closer to each other. In this case, the molecules will be very close to each other. These water molecules. But when we are supposed to heat, they move apart. So the molecules would be moving apart. So in a given unit, much mass would be there initially. But in the afterwards, the mass, that means mass per unit volume, there is nothing but density. So because of giving energy, the molecules of the liquid will be moving apart and density of the liquid gradually decreases. So density of the liquid decreases on increasing temperature. So what happens is initially the density of the sphere is less than density of liquid. Let us suppose that the density of the sphere is some 5 like that, simply for example 5. and density of the liquid is 7. So on heating, what happens is the value decreases suddenly. So the value of 7 decreases 7 to 6.5, 6.3, 6.2, 6.1, like that. Slowly, gradually it decreases and it becomes nearly equal to 5. Again it decreases. That means if we keep on heating still more, so again it would become density of the liquid would become 4. So now the density of the sphere is greater than, like that. So when the density is a little bit less than the density of the sphere, that means when it, suppose it is something like 4.95, like that. So it tends to, when the density is nearly equal, so at that time onwards the sphere tends to sink down. So finally that sphere sinks down. So as we are giving here heat energy, the molecules of the liquid move apart, because of which density of the liquid decreases. So because that is nothing but increase in the, so because of that the sphere would tend to sink down, because of which, so this is the case happening here. So now we need to find a coefficient of cubical expansion by this. So this is the concept here. So now let us see how to find the volume coefficient. So here you can see, here it is given that the expansion of the sphere is negligible as compared to the expansion of liquid. So we are just neglecting the expansion of the sphere. Actually the sphere also must expand, so it is also some sort of material, it also expands on heating, but here we need to just neglect it. So at 0 degrees centigrade, density of the liquid. So when the temperature is 0 degrees centigrade, density of the liquid they have given us here. So here they have provided us, here we can see density of the liquid at 0 degree centigrade. So that is 1.527 grams per centimeter cube. At 35 degrees centigrade, the density of the liquid equals the density of sphere. So this is very important, just now we have discussed. So 5 less than 7, density of the sphere, 5 less than sphere. So on heating, gradually the density of the liquid decreases, so finally it becomes nearly equal to the density of the sphere, and again it again decreases, so because of which the sphere tries to sink down. So the density of the liquid equals the density of the sphere. So at this point, so when it is going to sink, when the sphere is about to sink, so at that point density of the sphere is equal to density of the liquid. So now it is enough if we find at this point, if we find the density of sphere, then we would get the density of the liquid at 35 degrees centigrade. So that is the meaning of this point. So this is very important point. So based on this point, we are just finding here density of the sphere. So here you can see mass by volume. So this is the mass of the sphere, it was given 266.5. so this 266.5 and 4 by 3 pi r cube, that is volume of the sphere, spherical, 4 by 3 pi r cube, that is nothing but, so here radius, so they have given us diameter 7 centimeter, 7 by 2, d by 2, that is radius, that is 7 by 2, 3.5, so whole cube. So on doing this calculation, we would get finally this 1.484 grams per centimeter cube. And next thing is, so here density is nothing but mass by volume, mass by volume. So if we assume the mass of the liquid to be constant, so if we suppose the mass to be constant, so density is inversely proportional to volume. So here you can see density of the liquid at some temperature T by denoted by density of the liquid at 0 degree centigrade. So P is inversely proportional to V, so P theta V theta inverse proportional, and P naught V naught inverse proportional. So hence we are having P theta by P naught is equals to V naught by V theta. So this is the thing, and this is nothing but 1 by 1 plus gamma delta. So we know that V of theta, volume at some particular temperature, is nothing but, that is actually we know that V theta minus V naught by V naught into delta T is equals to gamma. So this is nothing but gamma. this term. So volume or expansion coefficient. So if we just interchange this, A equals to, so this is equals to gamma like that. So if we just send this to that side, V naught and V naught plus V naught gamma, V naught theta gamma. So that is, we would get V theta equals V naught into 1 plus 1, that is 1 plus gamma theta. So this is the thing you are gonna get. So now next what we need to do is we need to send this to that side, that is 1 by 1 plus gamma, and here V naught by V theta. So if we do this, we would get this. So this is the expression we are getting. So we are getting this from this term. So that is the thing. So from the volume expansion coefficient, we are going to get that term based on volume expansion coefficient. So next thing is formula. So this is the formula, and we need to find rho theta. So sorry, gamma we need to find out. So we just need to know, here we are sending this P naught to that side. So again, what they are doing is no need to send that to that side. So if we send this term to that side, that means if we take reciprocals on both sides, we would get 1 plus gamma theta is equals to rho naught by rho theta. And if we send this 1 to that side, minus 1 we will get. So gamma theta is equals to rho naught minus rho theta by rho theta. Rho naught minus rho theta by rho theta. So just sending this delta to this side, so delta t. So this is the formula we are getting. So rho naught minus rho theta is nothing but 35 degrees centigrade temperature, and divided by rho 35 into, and here temperature difference, so from 0 to 35 degrees. So initially it was at 0 degrees and we are heating it to 35 degrees centigrade. So that's why change in temperature is 35 degrees centigrade. So from this we are getting this formula. So this is the formula, and now we just need to substitute the values. So rho naught initially at 0 degree centigrade density, and at P theta density is 1.484. So 1.527 minus 1.484, and this is the density P theta P35 and into 35. So if we solve this, finally we will get this as the answer. So 8.28 into 10 to the power of minus 4 per degree centigrade. So this is the volume expansion coefficient. So finally this is the answer for this question based on this formula on substitution. So this is the concept. So this is the problem. So thank you.